On August 5, 2026, a dead Falcon 9 upper stage struck the Moon at about 8,700 kilometers per hour. This was not a planned lunar experiment. It was abandoned hardware from a 2025 mission that spent more than a year wandering through cislunar space. Astronomers predicted the collision in advance and pointed telescopes toward the impact zone, hoping to capture a rare artificial lunar impact in real time. When the predicted moment arrived, most ground telescopes saw no obvious flash. Later, a lunar orbiter revealed that the impact had actually happened. The object came from the January 15, 2025 Falcon 9 launch known as Ghost Riders in the Sky. That mission carried Firefly Aerospace Blue Ghost Mission 1 and SpaceX's Resilience lunar lander toward the Moon on the same rocket. Once its payloads separated, the upper stage had finished its job. Unlike the reusable first stage, this second stage was never meant to land. Its high-energy mission left it in a huge Earth orbit, reaching beyond lunar distance instead of quickly falling back into Earth's atmosphere. The stage took roughly 26 days to circle Earth, repeatedly crossing the region of space where the Moon itself travels. Crossing orbits do not guarantee a collision. Usually the Moon and the rocket stage reached that crossing point at completely different times. Over many months, gravity and the tiny pressure of sunlight shifted the stage's path until its timing lined up with the Moon. Sunlight can really move objects. Photons exert a tiny pressure, and over months that small force can measurably change an uncontrolled rocket body's orbit. Astronomers tracked the object as 2025 OR10D and used telescope orbital calculations and spectroscopy to confirm it was spacecraft hardware, not an asteroid. Researchers estimated a mass near 3,900 kilograms and measured a tumbling period of roughly 7 minutes. By mid-2026, calculations converged on August 5 at about 6:35 UTC near the Bell and Einstein crater region. The exact spot remained uncertain because a hollow tumbling stage catches sunlight differently from moment to moment, slightly changing its long-term path. The stage hit it at about 2.4 kilometers per second, roughly 5,400 miles per hour. The Moon has virtually no atmosphere, so there was no air resistance to burn the stage up or slow it before impact. At collision, kinetic energy became fractured metal, pulverized lunar rock, heat, shock through the ground, and high-speed ejector. Before the crash, researchers estimated a crater around 40 meters across, though higher resolution images are needed for a final measurement. Models predicted much of the ejector could rise 15 to 20 kilometers, while a narrower central spike might send some particles much higher. Without air, lunar dust does not billow like smoke. Individual grains follow clean ballistic arcs under the Moon's gravity. Scientists hoped the flash or plume might be visible from Earth, because the site lay near the Moon's bright limb. But a small impact on sunlit terrain is difficult to see because the bright lunar surface can overwhelm a brief, faint flash. When the predicted moment came, ground observatories did not obtain a clear direct image of the collision itself. Astronomers still searched for subtle dust and chemical signature appearing immediately after the predicted collision time. The strongest confirmation came from South Korea's Danuri lunar orbiter, already circling the Moon with cameras able to compare the surface before and after. Danuri photographed the area before the collision and again afterward, revealing a new disturbed patch where none had existed before. The before and after comparison transformed an orbital prediction into physical evidence that the abandoned upper stage had reached the Moon. NASA's Lunar Reconnaissance Orbiter is expected to examine the site in greater detail to measure the crater and disturbed terrain more precisely. Because scientists know the impactor's identity, mass, approximate speed and trajectory, the new crater becomes a rare controlled reference for impact physics. Researchers can compare the known collision energy with the crater's real size to improve models of how lunar rock fractures, compresses and ejects material. The event also tests how dust moves during high-speed impacts, important because lunar dust can threaten instruments, optics, and future surface infrastructure. Today the moon is mostly empty. Future landers, rovers, power systems, and science stations could make uncontrolled impacts much more consequential. The crash highlights a growing cislunar debris problem. Earth-orbiting junk is heavily tracked, but objects traveling between Earth and Moon are harder to catalogue. Cislunar objects can be extremely faint, distant and influenced by Earth, Moon and Sun gravity, with sunlight pressure adding another subtle force. Because 2025-01D's origin is known, its spectrum and motion can help identify other mysterious human-made objects near the Moon. NASA's LCRS mission deliberately struck the Moon in 2009 to excavate material from a shadowed crater and search for water-related compounds. The Falcon 9 collision was different because it was not planned as an experiment. Scientists simply turned an unwanted outcome into a scientific opportunity. The impact did not endanger Earth and made only a tiny local change on a moon already covered by countless natural impact craters. Meteoroids hit the moon naturally all the time, often at much higher speeds, sometimes producing flashes visible from Earth. The crash raises a practical question. Who should ensure spent rocket stages do not wander unpredictably through the Earth-Moon system? As lunar traffic grows, disposal planning may need to become as important as launch planning, especially near valuable scientific and exploration sites. They want the crater's exact dimensions, ejector pattern, brightness changes and chemical signatures, revealing how much lunar material was excavated. A discarded rocket created a small scar, but the event connects orbital mechanics, lunar geology, debris management and the future safety of moon exploration. What looked like space junk simply crashing into the moon became a real experiment. One scientist did not design, but were ready to learn from. And as humanity sends more machines toward the moon, this accidental impact leaves one lesson. Reaching another world also means taking responsibility for what we leave behind.